Now we are going to talk about different isomers. You've probably heard this term, or I hope that you've heard this term before. And there are different kinds of isomers. So there's actually a whole bunch of different things, because as you can, or as you probably remember, there's a lot of different ways how you can basically connect carbon atoms, hydrogen atoms, carbon hydrogen atoms, and also then heteroatoms together to form like a whole variety of new components with all different properties. And there are two classes of isomers. One is called the structural isomers. Basically, there's like the arrangement of the atoms along a chain or inside a molecule is different. And then we have stereoisomers, where we still have the same connection between the atoms, but somehow the arrangement with like a certain point of reference is different, and we'll talk about each of these, so then it becomes clearer what I'm talking about. First, the structural isomers. There's first this group of these so-called chain isomers. We can see that here in the bottom left of the screen in this blue box, and you can quite easily see, for example, the example here for pentane and 2-methyl butane. And both have like the formula C5H12. So when we just look at the sum formula, we cannot say that why would they have like different properties. But it becomes clear that they have different properties when we, for example, look at the boiling point. And the boiling point of pentane is about 5 to 6 degrees higher than the boiling point of this 2-methyl butane. And why is that? Because the arrangement of the carbon atoms is now different. With the pentane, we get like a linear chain, 1, 2, 3, 4, 5 carbon atoms connected in like one straight chain, and then all, of course, saturated with hydrogen atoms. And for the 2-methyl butane, we still have a 4-atom carbon chain, 1, 2, 3, 4, but the 5th carbon atom that was previously also part of this longer chain is now rearranged into a methyl side group. And this, of course, makes different physical properties, for example, like the boiling point. So that's what we call chain isomers, because like the arrangement of the carbon atoms differs. Then we get something that's called positional isomers. You can see that here in this example, and here we have now a chloroatom attached to the molecules. And of course, also makes a lot of difference where this chlorine atom is attached. And for one is attached at the chain end, we call that 1-chlorobutane. And when it's like in the middle of one of the other carbon atoms, like in the middle of the chain, it's called 2-chlorobutane. And of course, this alters again the physical properties. And because the position of the chlorine atom shifts now, we call this a position isomer. And then we can have functional group isomers. We can see this here in this example with the propanol and the methoxyethane. And that they both have the sum formula C3H8O1. And in one way, we can arrange this basically also again in a chain, carbon, 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 oxygen. And the oxygen has again one hydrogen atom. And we call this an alcohol because it has like an OH group attached at the end. But we, of course, can shuffle this arrangement around, and then we maybe arrange it in such a way. Carbon, carbon, oxygen, carbon. And then the molecule still fulfills the sum formula, but again, the physical properties change a lot, and it's also not the same functional group anymore, because this is an alcohol and this is an ether, and they have substantially different components and also show different reactivity, as you probably remember from the introduction to organic chemistry. So this is quite substantial, and we call this a functional group isomer. So you've seen that in this case, for the structural isomers, we always have like a different arrangement of the atoms. We always have the same number of atoms and also in the same quantity for each atom type. But now the arrangement between the two, between multiple different atoms, becomes different. And with that, also the properties, also in chemical reactivity, physical properties, all of that changes a lot.